Good morning, students. Today I'm going to explain, or I'm going to continue the same chapter, nitric acid, and topic will be chemical reactions. In the previous video, I have provided reactions with alkalis, carbonates, bicarbonates, as well as sulfides and bisulfides. Here I'm going to explain the next chemical reaction of nitric acid, and that is oxidizing nature, oxidizing property. Nitric acid is a strong oxidizing agent. It is a very strong oxidizing agent. You can say is nitric acid itself reduces to nitric oxide, nitrogen dioxide, or nitrous acid and oxidizes other. Oxidizing property of nitric acid due to nascent oxygen, which gives on decomposition of nitric acid. So here I am going to explain oxidizing property of nitric acid, both dilute and concentrated, by using or by taking suitable reactions. Concentrated HNO3. One side I am taking concentrated, and at the same time I am taking dilute HNO3. When nitric acid concentrated decompose, it gives NO2 plus H2O plus nascent oxygen. This is very reactive. Nascent oxygen. It is called nascent oxygen. At the same time, if dilute nitric acid decompose, it gives NO, that is nitric oxide, plus H2O plus nascent oxygen. So here is the difference. When concentrated is taken, it is giving NO2. When dilute is taken, it dissociates and gives NO. So how will you remember? So very simple. If one you remember, another automatically you can. So here you can use, whenever you talk about dil, you say no. This is the key for, I'm giving a key for that you can remember it for the long time. So whenever we talk about dil, we have to say no. Then you will achieve the goal. Dil, no. Now we'll take example and then we'll understand how nitric acid oxidizes metals, non-metals, or inorganic compounds. Nitric acid, both the cases, concentrated or dilute, both will oxidize metals. I'm taking here reactions with metals and taking common example like copper, iron, zinc. Same here, copper, iron and zinc. Okay. So concept is, what is the concept? Concept is when metal react with HNO3, concentrated, I am talking about concentrated, it will give metal nitrate plus these two product will give in all the reaction, NO2 plus H2O, and as we know that NO2 is a gas and which has reddish brown color. This O helps in oxidation of metals to the respective metal nitrates, or you can say that nitric acid is a powerful oxidizing agent, and the nascent oxygen formed on the decomposition oxidizes hydrogen to water. So here is the short form of the reaction. It is not dealt in a detail in your syllabus. So you can memorize the reaction, and I am giving the key how to memorize. It's very simple. When taken concentrated, these two products will form surely. Okay. In the same time, if you have taken here metal plus dilute HNO3, you can see that these two products will surely give NO plus H2. As I said that when it comes word dil, you say no. It means here gives NO plus H2O, as well as here also give metal nitrate. See, very simple differences here. If you have taken concentrated, it is giving NO2. If you have taken dilute, it is giving NO. And the rest of the products in both the cases, either concentrated or dilute, are same. Okay. So write here reaction HNO3. I am writing only one, and rest you have to practice. HNO3 dilute. So follow the concept. It is concentrated, surely it will give NO2 plus H2O. At the same time, when copper react with dilute, what will give? It will give NO plus H2O. Okay, and both the cases you can see it is giving metal nitrate, it is also giving metal nitrate. Only difference is NO2 and N. What will be the formula? How to write formula? It's very simple, just to break into ions. As we know that copper is divalent, nitric acid, it will dissociate into H plus and NO3 minus, or if you remember the concept, will give metal nitrate. What is the formula of nitrate? NO3 minus. Cross multiply, this 2 will go that side, 1 will come this side. What will be the formula? CuNO3 whole twice, copper nitrate. So your formula will be CuNO3 whole twice. And you can see that the same product is forming here metal nitrate. Which metal taken? Copper. So what will be the product here? Here also will be CuNO3 whole twice. And similarly, you can practice the rest of the reactions. Now question is it balanced reaction or not? This is not balanced reaction, and it is difficult to balance. But in case of dilute, you must remember the metal balancing will start with 3. Means here will be 3. If once one you are knowing, the rest you can practice. So how many copper is 3? How many copper is here? 1. So make it 3. Okay. Now you can see how many nitrogens are total. Here 3 2s are 6 and 1 7. It is odd number. You try to take it as an even number. Make it even. So write it here 2. So how many? 3 2s are 6 and 2 8. Now it is even number. Now nitrogen is here 8, and this side is how many? 1. So make it 8. Okay. Now next is hydrogen. How many hydrogen? 8, and that side you can see is only 2. So multiply here by 4. Now the rest which is left, oxygen. You can see count 8 3s are 24, and right hand side 3 2s are 6, 3s are 18. 18 plus 2, 20, and 20 plus 4, 24. Oxygen is also balanced. So you must remember reactions should be balanced, and you keep practicing balancing. If you wants to know the method, you see the video that I already have uploaded how to balance chemical equation on my channel. Now this reaction, is it balanced or not? See, no, it is not balanced. Again in practice, how many nitrogens are total? 2 plus 1, 3. So it is even, make it, so it is odd, make it even, multiply it by 2. Now nitrogen is 4. So here write 4. Now how many oxygen? 4 3s are 12. And this side 3 2s are 6, 2 2s are 4, 10, and 1 11. 1 is left, multiplying it by 2. Now oxygen is 12. Which is left? Hydrogen. Hydrogen is 4, and here hydrogen is also 4. So the reaction is balanced. I hope I'm clear. Now we'll move to the next property or next reaction under the same heading, oxidizing property. Here we saw reaction with metals in both the cases, concentrated as well as in dilute. The next point given in your book that dilute nitric acid can't oxidize non-metals, but concentrated can oxidize non-metals. So the next topic is oxidation of non-metals by using concentrated nitric acid. Your reaction is with non-metals. In your syllabus, given 3 non-metals: carbon, sulfur, and phosphorus. Reaction with concentrated nitric acid. Again concept. When non-metals react with acid, nitric acid, okay, we are talking about nitric acid, or nitric acid oxidizes non-metal, it will give these two products. Surely these will be the products. As well as here you have to memorize the products. Here there is no concept as we saw in the previous. If you have taken carbon dioxide, it will give this. If you have taken carbon, it will give carbon dioxide. If you have taken sulfur, it will give sulfuric acid, and if you have taken phosphorus, it will give phosphoric acid. That you have to memorize, and the rest product will be same in all the cases. It means you have to memorize only the main product, and these NO2 and H2 will be same in all the cases. Yes? Now reaction is balanced or not, you have to check. It is not balanced, and that we have to do. I'm not going to do here, you have to practice it. So the reaction of non-metals with concentrated nitric acid is over. Now we'll move to the next topic under the same heading, oxidizing property. One point is given in the book, that is passive iron. What is passive iron, or what is passivity? So we'll try to understand what is passivity. Metals like iron, aluminium, cobalt, and nickel, when they are treated with pure concentrated nitric acid, they become inert. They become inert. You can use passive word. Inert or passive means they are unreactive. Why they are unreactive? So question, if come, what is passivity? Yeah, what do you mean by passivity? So answer will be, when metals like aluminium, cobalt, nickel, iron is treated with concentrated nitric acid, a thin film of, or formation of thin film of, or you can say extremely thin layer of insoluble metallic oxide, which stops the reaction. Once again, when these metals are treated with concentrated nitric acid, formation of extremely thin layer of insoluble metallic oxide which stops the reaction. This is called passivity. Then question can come, how to remove passivity? So there are two methods. The first method is, if this passive metals or passive if iron is become passive, that is called passive iron. So these metals, when the surface of these metals when rubbed with sandpaper, you know the sandpaper, before painting we rub the metals, that is called sandpaper, that is kind of paper. So the surface is rubbed with the sandpaper, then its passivity or the passivity of metals will get over. One more method is given in the book, that is called, when these metals, these passive metals, when treated with strong reducing agent, then the passivity can be removed. So mark this topic, this is very important. Now I'm going to the next segment. As we know that dilute acid is generally considered as a typical acid, except for its reaction with metals, since it does not produce hydrogen when react with metals. It is a powerful oxidizing agent, so it oxidizes hydrogen into water. But there are two metals which can react with very dilute nitric acid and produces hydrogen gas. These two are exception. What I said, nitric acid is a very typical acid. Generally it doesn't produce hydrogen gas when react with metals, because it oxidizes hydrogen to or into water. But here again exception, in chemistry there are so many exceptions. There are two metals which can be oxidized or react with very dilute nitric acid and produces hydrogen gas. So we are going to study the third category of nitric acid, that is called very dilute nitric acid. These metals, manganese and magnesium, they can react with HNO3. It is very dilute. It is very dilute. When these metals, question can come, which metal can react with very dilute nitric acid and produce hydrogen gas? So answer will be manganese and magnesium. So when they react, they give metal nitrate. What will give? Metal nitrate plus hydrogen gas. Same way, will also give metal nitrate plus hydrogen gas. So what will be the formula of metal nitrate? Which metal is taken? Mn. And as we know that Mn is divalent, and you know the formula of nitrate. Nitrate formula is NO3 minus. Cross multiply, so get the formula MnNO3 whole twice. And similarly, magnesium is also a divalent, so it reacts with very dilute nitric acid and it will give MgNO3 whole twice. So question can come from here. Name the metal which can react with very dilute nitric acid and produces hydrogen gas. So answer will be manganese and magnesium. Understood? Now one more topic I am going to give in this video, that is aquaresia. What is aquaresia? What do you mean by aquaresia? That is already is dealt in the chapter SCA, but again we will see here what is aquaresia. When 3 parts of concentrated HCl is mixed with 1 part of concentrated HNO3. This mixture is called aquaresia. What is called? This mixture is called aquaresia. Question can come. What is aquaresia? When they mixed, they form product NaCl. Its name is nitrosyl chloride, as well as it gives water plus nascent chlorine. So here question 2-3 questions are possible from here. So first question is what is aquaresia? Second question can come, which noble metals can dissolve in aquaresia? Answer is gold and platinum. Or in the other way it is also may be asked, in which solution noble metal can dissolve? Answer will be aquaresia. Generally we know that these noble metals gold and platinum doesn't react with any chemicals because they are very less reactive. We have studied activity series and they are placed below in the activity series, means they are very reactive, very unreactive, or they are non-reactive. So we can see here, platinum will react with aquaresia as well as gold can react. Platinum is tetravalent. This is trivalent. When react with nascent chloride, which is very reactive, it gives PtCl4, platinum tetrachloride, and here it will give auric chloride, AuCl3. AuCl trivalent. Balance it, you will be 3, there will be 4. This is called aquaresia, and these are the reactions possible when gold and platinum react with nascent chlorine. Again, I am going to end this lesson here, this topic here, because it will be too long. I will provide one more video, and in that video I will explain what are the effects of heat on nitrates, as well as I will explain what are the tests for nitrate ion and nitric acid. And we'll also see in that video, or I will give uses of nitric acid. I'm going to end this lesson here, topic here. So if you liked my video, you must subscribe my channel to get more updates. Thank you.